In this experiment, you'll measure the magnetic force between two current-carrying wires. This is the equation for the magnetic field produced by a long wire, and this is the force that magnetic field would exert on a second current. In our setup, this variable transformer allows us to vary the voltage we draw from the outlet. The second transformer ensures that we have a high enough current to get a significant magnetic field. Current is fed through the upper U-shaped rod and the lower horizontal rod in the current balance. The right-hand rule gives the direction of the magnetic field produced by a wire. Magnetic fields exert no force on currents that are parallel to the field. Therefore, only the two parallel segments of the rods will exert force on each other. We reflect a laser beam off this mirror attached to the current balance and onto a distant wall. By marking the position of the laser beam on the wall when no forces are applied to the current balance, we can detect the tiny deviations produced by the relatively weak magnetic force of the single wire, and measure that force by balancing it with masses added to the current balance. A multimeter is used to measure the current through the apparatus. It should be set to measure alternating current, and the high current port should be used to avoid blowing the fuse. Putting current through the circuit causes the wires to repel each other. Tiny masses can then be added to the current balance tray to lower the balance arm, and then the input current can be adjusted so that the laser goes back to its initial position, showing that the gravitational force on the mass and the magnetic force are in balance.